Jungle.
Okay, the first reactions of alcohol is combustion, and then the second is about oxidation. While combustion reactions use oxygen direct from air, the oxidation reactions use the oxidizing agent as the source of oxygen. Okay, the types of oxidizing agents that can be used in oxidation process are potassium dichromate K2Cr2O7, which the color will be changed from orange to green as the oxidation process occurs. And you can also use potassium manganate, acidified potassium manganate, KMnO4, with the change of color purple to colorless. Okay, this is a breathalyzer test when a bag contains potassium dichromate crystals, used to detect whether someone in in not in best conditions when they drive the car or not, because sometimes they just drunk, after that they drive the car. So police will try to make the very fast analysis, to find out whether this man is drunk or not. Okay, this is potassium dichromate K2Cr2O7. So if this man breathes and then the crystal turns to green, okay, that means his breath is full of ethanol vapor. Okay, so the police can arrest these people, this man. Okay, so this oxidation process once again is important to detect the presence of alcohol. Is it work? Do you think it is work? No, it is not work. This man still go to the jail. Okay, oxidation of alcohols. We will start from the primary alcohol. So that's why at the beginning I already told you about the types of alcohol, primary, secondary, and tertiary, since they undergo differentiations. I mean to give different product. Okay, we will start from the primary alcohol stuff, and it is ethanol. Okay, you know that ethanol, this OH, attached to this C, and this C has to another H group. Okay, OH attached to this C, and this C has to H group. This H called as carbonyl hydrogen. So this, same. So there are two carbonyl hydrogens. Please remember, in oxidation process, oxygen from oxidizing agent, so potassium dichromate will release oxygen. The oxygen from the oxidizing agent will attack the carbonyl hydrogen. Please remember. Okay, not this H, not this H, not this H, but hydrogen at the C that bonded to OH. Okay, you should understand this first. So what happened? Oxygen will attack one of these carbonyl hydrogen. Okay, let's say attached to this H, so it will change to OH. The oxygen will insert here. Okay, the hydrogen should be moved, to make the compound with two OH group at the same C. Okay, two OH at the same C makes this compound unstable. So what happened now? It should remove water molecule. Condensation reactions will be occur. How to remove the water molecule is by get one H from one OH, and the other OH will be removed. Okay, you can see that water will be released here. As the water molecule release, you can see that this free hands, right? Oxygen also has free hands since H has been released, right? This free hand and this free hand can combine to form aldehyde functional group. Okay, once again, this is OH, this is OH, this remove. Okay, this hand with this hand, you know that this hand contains of electrons, right? Electron and electron combine to form double bond. Yeah, so this is aldehyde functional group. You can see C double bond OH. So that's why like this. Okay. So now we already have aldehyde. Aldehyde still has hydrogen. Yeah, you can see that this hydrogen still, yeah, still carbonyl hydrogen, right? Still appear at the beginning. Yeah. So aldehyde can undergo further oxidation. Once again, if potassium dichromate in excess, yeah, it still supply oxygen. Oxygen will once again attack this hydrogen, okay, to form OH group. It will go insert this to form OH. So you can see that the carboxylic acid will be formed. Okay. So the summary is ethanol change to ethanol and change to ethanoic acid. But you should remember about the conditions of how we stop this process until aldehyde, ethanol, or continue until ethanoic acid produced. You should understand the conditions. To stop reactions at ethanol stage, we should distill the ethanol from the reaction mixture as soon as it is formed. Why? Because the boiling point, just 20.8, very different from ethanol, which has hydrogen bond. Yeah, ethanol has no possibility to form hydrogen bond. You know that ethanol CH3 COH, yeah. Even it has lone pair from oxygen, it does not have the positive H, right? Since this H attached to this C, so it doesn't create dipole. So since it doesn't create dipole, it doesn't has capability to make hydrogen bonds. Okay, so low boiling point. You can distill the ethanol soon it is formed. But if we want to produce ethanoic acid, yeah, heat the mixture under reflux, yeah, so that none of the ethanol can escape. So the point is distill if you want to stop at ethanol stage, reflux if you want to get carboxylic acid. Okay, distillation requires gentle heat. Okay, let me zoom this. Okay, this is distillation. Just yeah, just require gentle heat. Yeah, since it is less than 100 degrees Celsius, right? Okay, you can see that this is where the primary alcohol and the oxidizing agent place. Okay, and then the oxidation reactions will occur, and because of ethanol has lower boiling point than ethanol, it will vaporize and then goes here. Okay, and you know that this condenser has a function to condense the vapor to liquid form, right? So this is liquid ethanol as distillate, and we call as distillate. Don't forget, in condensation reaction, the water in should be here. This is in and this is out. Okay, to make sure that the temperature still low, yeah, at this point. Okay, since if not, the liquid will change to vapor again. Yeah, we want to prevent that to happen. Okay. Okay, so once again, distillation, if you wish to produce aldehyde, and this is called as reflux. The position of condenser is like this, yeah, vertical. So that means if, oh, one more, yeah, this require a constant heat, yeah, higher temperature compared than distillation. So we need to use the boiling flash, yeah, called as round bottom flash, and you need to give the boiling chips here, since if not, the flask could be break, yeah, since a very high pressure inside this flash. Okay, so boiling chips needs to make sure only the small bubble form, yeah. Okay, and then as the boiling point reach, okay, you know that ethanol changes to ethanoic acid in this process. Okay, and the vapor will goes here, yeah, will try to escape to the environment. Okay, look here. But since at this condition, the temperature fall, so it will turns to liquid, right? So the vapor will turns to liquid again and back here. So this process like a cycle. Okay, vaporize, turns to liquid, goes back, vaporize again, and like this. So this process makes sure that all primary alcohol will be oxidized to form acid, carboxylic acid. Yeah. Okay. Once again, this process called as reflux. Yeah, heat at reflux. Okay. The primary alcohol gives aldehyde and carboxylic acid as the product, while the secondary are oxidized to form ketone. Okay, you can see here that this is secondary alcohol since OH attached to the C that bonded to 2R group, right? This is secondary. So we just have one hydrogen, the carbonyl hydrogen, right? And I already told you that oxygen from oxidizing agent will attack this hydrogen to form OH. Okay, the oxygen try to insert, yeah, to form OH bond. You know that 2OH bond is not stable once again. So it's try to make to produce water molecule through condensation reaction. Once again, now we have free hand and free hand. They combine to form double bond. Okay, R, R, C, O, R. So this is ketone. Okay. Can we change ketone to carboxylic acid with further oxidation? No, yeah. Cannot undergo further oxidation. So stop until here. But why? Since the oxygen no meet the another hydrogen, yeah. Jadi, there is no carbonyl hydrogen, yeah, in this C11O already full. There is no hydrogen that can be attacked by the oxidizing agent. So that's why it cannot undergo further oxidation. Okay, how about tertiary alcohol? The tertiary alcohol has 3R group, yeah, around the COH. So the oxidizing agent could not find any hydrogen, yeah, could not find any hydrogen around this carbon. So tertiary alcohol will not undergo oxidation process, yeah. So oxidation only occur in primary and secondary alcohol. So we can distinguish the primary and secondary from the tertiary by using the observation of how the oxidizing agent changes the color. If it changes color to green, that means oxidation reactions occur because Cr2O72 minus, yeah, yellow orange, changes to Cr3 plus if the oxidation reactions occur. Okay, then the color changes from orange to green. But if the oxidation reactions does not occur, it's still in Cr2O72 minus form, which has a orange yellow color. So through this process, we can distinguish whether it is a primary, secondary, or tertiary. But once again, we cannot distinguish the primary and secondary through this type of reaction, since they produce the same color, which is green.